So let's talk about how to approach math problems when units are involved. And this is important because in the real world, you're never going to have a problem with just numbers. You're always going to have some units in there as well as the numbers. And I know it can be pretty tempting to just ignore the units. I see students doing that a lot, just because it can seem strange to do math with things that aren't numbers. But you're going to run into all sorts of problems if you just ignore the units. So let's just go over a few rules to follow so that you can be comfortable with doing math with units as well as numbers. So first off, just as an example, I wrote down 3 feet. I know you know what 3 feet means, but let's sort of break it apart, and you might be surprised. So 3 feet, of course, that's a length. So if we just have a length of 3 feet, so let's see, we got about 1 foot, 2 feet, 3 feet. So this is really 1 foot 3 times, right? So rather than thinking about this as just 3 feet, you can actually think about this as a number and a unit separately, and they're actually multiplied together. That might seem weird. Why is it multiplication? Well, that's sort of the definition of multiplication. You have 3 feet, you have 1 foot 3 times. That's just how we define multiplication. So you could actually write this as the number 3 times 1 foot. And it can seem strange to write it that way, and usually you don't have to write it that way. But there's a lot of times when you're doing a math problem that you may not need to write it this way, but at least you need to understand that these are 2 separate objects and they're multiplied together. So I wrote down just a couple more rules, things to keep in mind when you're doing math with units. So the first one is sort of what we're talking about here, and that's just to treat units algebraically. And that might sound kind of complicated, but it's not so bad. You can think of algebra as just a set of rules for how to do math with numbers and things that aren't numbers. Since units aren't numbers, they sort of fall into the category of algebra. But the reason this is not so hard is that the rules that you use for doing math with things that aren't numbers are the same rules that you use for doing math with numbers. So I guess this whole first point can really be summed up with 2 parts. First, when you have a number that has a unit assigned to it, think about them as separate objects that are multiplied together. And then you can think about when you're faced with doing math with units, just think about following the same rules that you know to follow for numbers. Use those same rules for units. I know that can seem a little strange and foreign, but I'll do a bunch of examples here, and I think you'll see what I mean. The next bullet here is just that you can only add and subtract units of the same type. And this is pretty simple. So if you have 3 feet plus 2 feet, this problem is every bit as easy as you think it is. We're just taking a length of 3 feet, adding a length of 2 feet. They're the same type of unit, so we'll just get a longer length, 5 feet. No problem there. But if we were to add 3 feet plus 2 inches, we really can't combine these 2 units. This is just 3 feet and 2 inches. That's about all we can do. The only way you might be able to think about solving this problem is doing a unit conversion. We could, for example, convert this to inches. We know that 1 foot is 12 inches, so if we have 3 feet, we have 36 inches. And now, because we have the same unit type, we can combine these and say we have 38 inches. So that's one way to approach that problem, but short of doing a unit conversion, there's really no way to combine or subtract units that are a different type. And then the last bullet point that I wrote down here is that when you multiply or divide units, the result is a new type of unit. And this is probably the most interesting part of doing math with units, and it can also seem the most foreign, which maybe is the most difficult. And it's super important. And right now I want to go over a bunch of problems where we're multiplying or dividing units of the same or different type, so that you can see that we're going to end up with new types of units. Let's do these. Let's do this problem first. 3 feet times 2 feet. So the first thing I'm going to do here, remember 3 feet is actually 3 times a foot. So I'm going to rewrite it like that. I'm going to write this as 3 times a foot. And then I have times 2 feet, so I have times 2 times a foot. Now the rules of multiplication say we can multiply things together in any order that we want. So I can actually sort of regroup this and say, I'm actually going to do this as 3 times 2, and then I'm going to multiply that by my foot times my foot. Okay, so we can multiply numbers very easily. We like that. That's 6, and then we have times, and then we have a foot times a foot. So now we're multiplying 2 units together, and how are we going to do this? Well, when we multiply 2 units together, we get a new type of unit. And in this case, we're multiplying a length. So we have a length of 1 foot, and we're going to multiply that by a length of another foot. And when we multiply 2 lengths together, you get a new type of unit. You get a unit that describes surface area. So in this case, a foot times a foot is a square foot. 1 foot times 1 foot equals 1 square foot. And that's really just something to memorize. A foot times a foot is a square foot, and that's a unit that describes surface area. And you'll see that abbreviated as foot to the power of 2 very often, and that's fine. You can abbreviate it that way, but it's still just pronounced square foot. That's just an abbreviation. So if we come back here, we know that a foot times a foot is a square foot, so now we have a 6 times the unit square foot. And of course, we don't need to write this multiplication sign between our number and our units, so our answer here is just 6 square feet. Okay, what about this problem here? 3 feet times 2 feet times 2 feet. So I could break this all apart like I did up here, but you don't usually need to do that. What we figured out here is that we can just multiply the numbers, and then we can multiply the units, and we can do those things separately. So 3 times 2 is 6, times 2 is 12. And then we need to do a foot times a foot times a foot. Well, we know when we do 1 foot, when we do 1 foot times 1 foot, we get a square foot. But what if we multiply it by another foot? Well, we're adding another dimension here. Adding another dimension, we've multiplied it by another foot. Now we have a unit that describes volume. So now we have a cubic foot. So 1 foot times 1 foot times 1 foot equals 1 cubic foot. You'll see that abbreviated a lot as foot to the power of 3. But again, this is just an abbreviation for cubic foot. So you still just pronounce this as cubic foot. So our answer here is going to be 12 cubic feet. That's it. That's a measurement of volume, 12 cubic feet. Let's go on and divide some units. So now we have 50 pounds divided by 25 square inches. So division, of course, you should always write as a fraction. This is actually 50 pounds divided by or over 25 square inches. So this is really just a matter of simplifying this fraction. You can think of this as 50 divided by 25, or you could think about this as just 50 over 25 and simplifying that. So if you do that, you would get 50, and I'll just leave my units. It's 50 times a pound, right? This is 50 times a pound, and 25 times a square inch. So if we simplify this, we can really just say this is 2 times a pound over 1 times a square inch. And then, so what does this mean? So this is 2 pounds over 1 square inch. I don't really need to write this 1. This is just 2 pounds over square inch. So remember, division, you can always pronounce division as the word per. The division means per, so this is really 50 pounds per 25 square inches, or 50 pounds for each 25 square inches. So here I could say this is really 2 pounds per 1 square inch, or just 20 pounds per square inch. So you'll see that abbreviated really as just 2 pounds per, you can use just a slash as a fraction bar, per square inch. That's really it. I haven't really combined these units. There's two distinct units, pounds per square inch, but this really is, you could also think of this also as a new type of unit, pounds per square inch. And there's actually a separate abbreviation for that unit, to PSI, right? Pounds per square inch, PSI. And that's a unit of pressure. So 2 psi is 2 pounds per square inch. It's a unit of pressure. So I've taken 50 pounds, divided it by 25 square inches, and I get 2 pounds per square inch. So I've taken a weight, divided it by an area, and I've created a pressure. And you can think about that. That sort of makes sense. It's 50 pounds per 25 square inches, or you can think about this as a weight of 50 pounds distributed over an area of 25 square inches. So that surface area is experiencing a pressure of 2 pounds per square inch. Okay, what about this one? 15 feet divided by 5 feet. So we'll start just as writing this as a fraction. This is 15 feet divided by 5 feet. Let's just think about simplifying this fraction. Well, one way we can do this is we could say this is 15 times a foot. That's one way to do it. Times a foot, or 5 times a foot. 15 over 5. We could really simplify that. That's just 3 over 1. Or we can just do 15 divided by 5 is 3. Same thing. 15 over 1, and then we still have this times a foot. Times a foot. And we can think about doing the division separately. So what's a foot times a foot? Well, this is a situation where we need to think about what rules do we follow when we're dividing numbers, and specifically what about when we're dividing two numbers that are the same? So, for example, what if we had 6 divided by 6? I'm just making something up here. 6 divided by 6 is, of course, 1. That's true. Anytime you divide something by itself, you get 1. So that's true with numbers, and it's also true with things that aren't numbers. It's true with units. So a foot divided by a foot is 1. So essentially, these just cancel out. And you have 3 times, you could say you have 3 times 1 and 1 times 1. So this is just 1 on the bottom, and this is just 3 on the top, so this whole thing just equals 3. So if I have 15 feet divided by 5 feet, my answer is just 3. And notice there's no units here. And that sort of makes sense. We're saying 15 feet divided by 5 feet. So how many times does 5 feet go into 15 feet? Or how many lengths of 5 feet are there in 15 feet? And there's 3. It's just the number 3. So that's it.